Hello and welcome everyone to this tutorial on how to build REST APIs in Node.js. But before we go ahead and develop the REST API using Node, it is important that we first comprehend what exactly an API is. Consider this example. Imagine you're dining out and you want to order food. Since you are in a restaurant, you won't go directly into the kitchen and start preparing it yourself, right? Instead, you communicate your order to the waiter, who then delivers your request to the kitchen. The kitchen prepares your food and the waiter brings it back to you. Similarly, in software, an API allows different applications to communicate with each other without you having to understand the complexities of how they work internally. REST is one type of API that is commonly used in mobile and web applications. It stands for Representational State Transfer. And today, with this video, we are comprehensively going to break it down. But before we do that, make sure to subscribe to Intellipaat's YouTube channel and enable the bell icon to never miss any update coming from our team.
So what are REST APIs? Let's take a look at what a REST API is. So REST API is obviously an API, but it's a very specific kind of an API. So REST API or RESTful API is essentially an architectural pattern. It's a way of creating an API. So you could technically create a URL endpoint that when a user hits that URL, let's say google.com/verify, and when you click that URL, it sends back some response. That technically is an API, but it's not a REST API, mainly because REST API is something that is used to define a set of constraints while building web APIs. So let me give you an example. Suppose that when you're building a web API, you are trying to expose some information from your database securely. Such in the case of Google, they are trying to figure out whether or not this person with this username and password exists in the Google servers or Google databases. So this is what we're trying to do in a REST API. We're trying to take a web server, we're trying to take a database, and we're trying to connect them and then allow anyone to access or ask a specific question regarding the data inside the database. So in our example that I've shown below, what happens is we firstly use some methods. Methods are nothing but HTTP protocols. In case you've not learned HTTP, this is going to sound very foreign to you, but stick with me and I hope you understand this. So basically, when you send an HTTP request, there are a few parts to it. Firstly, the header, and secondly, the payload. The header is the thing that describes your request, what kind of request it is, where is it coming from, is there any other authentication information that has been embedded, and then there is the payload, which is the body of the request, or which is the additional information that you send with the request. And so one of the things that we put in the header is the method. Method allows the server to understand what is this request trying to accomplish. So if it's a get request, basically it's trying to get some data from the server. If there's a post request, that means it's sending some data for us to process, whether to save it in a database or save it in a file or do something with it. If it's a get request and it has a user ID in the URL, that means that it's trying to get some information from our database servers with a particular ID. So in a database, we have particular IDs associated with it. These are called primary keys that happen to uniquely identify a user. So for instance, if you have been to a school, you are issued a unique number that is the roll number. That's the primary key in that scenario. And in databases, sometimes database generates random IDs so that they can assign them to the users and they can be uniquely identified. And then you can update the user and you can delete the user. This is also what's called a CRUD request: create, read, update, and delete. REST APIs are quite good at modeling CRUD requests. So you can take a look at that as well. Now, when it comes to the URLs, this is the pattern that we use when we're using a REST API. Essentially, a REST API is when you are trying to build an API to expose a particular resource. In our case, we are trying to expose our users. We follow this pattern. In case it wasn't users, then instead of /users in the URL, we would have the entity's name. Let's say that we were trying to expose to-dos. You have a to-do list API in which a user can add to-dos. In that case, we will make a request to the domain /to-dos. That's the way that works. So now we go on to understand what is ExpressJS. In case you don't know what ExpressJS is, let me just explain. So ExpressJS is a web application development framework based on Node.js. So Node.js is the language It's essentially a language runtime that allows you to write JavaScript for the server side. ExpressJS, on the other hand, takes some of the common tasks that you have to perform. So some of the common tasks that are related to building a web application or a web API are parsing the request, getting the cookie information, getting the data formatted correctly. All of this is something that we have to do every time. ExpressJS is a built-in solution for that. So you can use that and you don't have to worry about all the plumbing of the entire web API. You can just follow on solving the problems that you have to solve in order to build the web API, building the business application, so on and so forth. So why should you use ExpressJS? Well, let's take a look at some of the advantages that ExpressJS provides. It's fast. ExpressJS is a really lightweight framework. It's a micro framework, so it does not expect you to be able to define everything. You can do it, and will do this quite easily. So you don't have to worry about it. ExpressJS is really easy to use. So it's really fast because it's really small and it doesn't contain a lot of things for the web server to go through. So it's a really small framework and it's really easy to understand as well. It's very minimal. So minimalism is essentially, in the case of ExpressJS, means that it provides the fundamental web application features. So everything that has to do with parsing the request, to formatting the data, to extracting the data from a request is done by ExpressJS. And since it's minimal, it only takes care of a few subsets of the problem. Rest, either you can plug into the ExpressJS using its plugin architecture, or you can write your own code, or you can use other libraries to do the other things as well, such as database access, routing, caching, and so on and so forth. It's unopinionated. So for those of you who don't know, unopinionated means that it does not have any preconceived notions about how your application should be structured. You can, if you wish to build a REST API in ExpressJS using a single Node.js file. So everything that you have to write, every code that you have to write, you can write it in the single file and it will work just fine. But in case you want to break them into smaller pieces so that they are easy to manage, you can do that as well. ExpressJS doesn't care, and this is different from other frameworks such as Ruby on Rails and many other JS frameworks as well, such as Kraken.js, where they have a predefined set of rules. They have their own directory structure that you have to follow. You can configure them, but basically they come with a predefined structure. And here in ExpressJS, you don't have any predefined structure. You can build it yourself. They're very simple. So since ExpressJS is a micro framework, it doesn't take care of a lot of things. So it's very easy to get started with, and it's very easy to use. So in case you wish to use ExpressJS, you can get started with it very quickly. Just make sure that you understand the basics of internet, how internet requests work, what is the typical format of an HTTP request. If you understand the basics, you can very easily pick up ExpressJS. It's very easy and very simple to use, and it's unobtrusive. So unobtrusive basically means that it provides unobtrusive basically means that it does not disallow people or developers to make choices about the kind of things that they wish to use. So for instance, you can use any library that you want to use. You can use any database. You can use an in-memory database if you wish to. ExpressJS does not disallow people from using the kind of things that they want to use. Although some things could be very difficult to integrate with ExpressJS, and some things could be very easy to integrate with ExpressJS. Depending on what you're trying to do, it can work that way. So now let's take a look at MongoDB. So we use MongoDB to store data. It's a NoSQL database. But the reason we're discussing it here is because in our demo, we'll be using MongoDB, and MongoDB is the most popular database system that is used with Node.js and ExpressJS. So you should be familiar with MongoDB. Even if you don't use it, you should at least know the basic concepts. So let's take a look at that. So MongoDB is a document-oriented NoSQL database management system. So NoSQL databases are basically databases that allow you to store data. Typically, when you used to store data in SQL databases, you used to store them in tables, in columns and rows. Basically, you used to store them like an Excel sheet. Not you wouldn't be storing them in an Excel sheet, but the format would be similar. You would have a table, it would have rows, it would have columns, and in those tables you can configure constraints, primary keys, secondary keys, so on and so forth. In NoSQL databases, you can store data in different formats. So MongoDB is a document-oriented database. That means that you can use the JavaScript object notation or the JSON format and store unstructured data. There are no constraints as such. You can put the constraints yourself, but by default, you can just put in data of any shape in your MongoDB collections and you can retrieve it. It's written in C++, so it's really fast, and so it's much better than an in-memory database because it stores these things in the database's disks, so that even if the database is rebooted or it crashes, the data will still remain intact. So why would you want to use MongoDB? Although there are many other NoSQL databases such as Neo4j, which allows you to model your data in a graph, to Cassandra, CouchDB, there are many others as well. Why would you want to use MongoDB? Again, MongoDB is really fast. It's written in C++, so it provides really high consistency and speed for reads and writes of collections and documents. Collections and documents, let me just briefly explain. When you're building a data model in Node.js, you have collections and documents. Think of a document as a table. So it's basically a group of collections, and a collection is a single row in the database. So if you have if you want to store data of some users, all the data stored inside the user's document, and each single row in the data or each single data about a user is a collection. It's flexible. So as you can see, it is as you can quite easily understand that MongoDB is schemaless. Now, schemaless essentially means that it provides the flexibility of inserting a record in any shape. Like I've already told you, there are no constraints by default. So if you wish to insert some data inside your MongoDB of one shape, as in it has two data points, such as if you're trying to store a user, you can store their first name and last name, and in the next row you can store data that neither has first name nor has last name, just the date of birth. It would be really inconsistent for your database to keep track of things like this, but you can do it. So this is why NoSQL databases are preferred in larger organizations, because they allow developers to create applications on the go, and they don't really need to define a schema. They don't need to be mindful about certain things, but schema is not really the thing that they'll be really something that's in the back of their mind. And also it allows them to make it really easy for them to understand what the data is about. So that's why they use schemaless databases. No joins. So if you have ever used NoSQL databases, one of the most important aspects of of an SQL database is join. So if you have data stored in multiple tables, which is what good database design is about, you have to break every table into smaller pieces and then connect them using primary keys and secondary keys. And when you have to gather data from multiple tables, you use joins. Now, joins are really expensive. They take a lot of time. Many people get over this barrier by using caches. So they essentially just store the joined data inside an in-memory database. And when they want to get the data, they take a look at the cache first. If it's not available, then they perform the join, which is quite slow. Then put the data in the cache and then return it back. In MongoDB and other NoSQL databases also, you don't need to perform joins. Since the data has no schema, you can just embed one data point inside another data point, and that way you can just get all the data. There are certain constraints in certain databases, and you have to be mindful of this. But in general practice, you don't really need to worry about joins. So you can use databases without joins easily. Easy to use. MongoDB, if you have used JavaScript, then it's really easy to use. For those of you who have not used JavaScript till now, you can take a look at the MongoDB shell and interact with it. It's very simple, and it's very effective also. It's very much like you're trying to write JavaScript code. It's very object oriented in nature, and it's very easy to wrap your head around. As a developer, it's really easy to understand, and it's really easy to use as well. And scalability. So MongoDB allows you to deploy your clusters to cloud. MongoDB has their own cluster services, database services in the cloud. They allow you to create your databases and use your databases in AWS, GCP, and Azure. AWS is Amazon Web Services, GCP is Google Cloud Platform, and Microsoft Azure. So you can use that there as well. Also, MongoDB has several other features and several other tools that allow you to ingest massive amounts of data, and it is a really large ecosystem. So it's not just databases; it has other systems as well, such as data lakes and so on and so forth. You can use that as well. The reason why it's distributed in cloud, because it comes with a native support for distributed data, sharding, clustering, so on and so forth. These are concepts that you need to understand when you're trying to model data of a large scale. If you're trying to think of a database of a large scale, think of database of Google, which has so many users, or think of a database of Facebook. Right now, Facebook has around 2.4 billion users. Just storing their username and password in a single machine is not possible. So to do that, what they do is they create multiple machines and store data of particular users on one machine, and some other collection of users on other machines, and how they group these machines and how they spread data across these machines is a little different to understand. But the main point to understand here is that MongoDB comes in with the built-in support for these features, so that you can, when you reach a really high limit of users, distribute the data, scale it, and use it the way you wish to use. So now we'll take a look at Mongoose. What is Mongoose and why do we need it? So on its own, ExpressJS and MongoDB are two separate things. ExpressJS is a web application framework and MongoDB is a database. It needs a library that can be used to connect ExpressJS applications to MongoDB servers and fetch data and records and so on and so forth. And so Mongoose is an object data mapper, or ODM as it stands for. If you've used other frameworks such as Spring or any other framework like Ruby on Rails, Laravel, so on and so forth, you'll end up using something called an ORM. ORM stands for Object Relational Mapper. Here, since we're using objects and data, we're using ODM, or Object Data Mapper. Essentially, how you would do a typical REST API in a typical web server is that you get the data from the database. You then map that data into an object of your defined language. Let's say you are using Java, then you have to create an object, and then you get the data from the database that you have gotten, and you put data one by one inside an object, and then you return the object. Object data mappers you to let allow you to not worry about these kinds of things. What they do is they allow you to define the shape of the data, and what they will do is they'll get the data from the database and put them inside a document or put them inside an object and return you back the object the way you want it. Obviously, you can change the way it interacts with the objects as well, and it allows you to use those objects to interact with the database directly. So instead of issuing SQL queries in the case of SQL, and in the case of MongoDB, instead of issuing database commands, all you have to do is deal with the objects. It's very easy for object-oriented programmer to deal with objects, so that's why things like object data mappers or object relational mappers have come into play. So why should you use Mongoose? This should be noted that Mongoose is not the only library that allows you to interact with databases. There are other libraries available as well. To name a few, there is MongoDB. The name of the library is MongoDB. It's created by the creators of MongoDB for Node.js and ExpressJS. The only problem with MongoDB is that it's not an object data mapper. So like I've said, you need to get the data and then map it to the object and then return it back. And to use get data, you have to get the collections, define the collections, you have to work with all the internal plumbing of dealing with the database. While in Mongoose or other object data mappers or relational mappers, you can just leave the internal mappings to the library itself and focus on the code and the relationship between the data sets. So Mongoose provides several benefits for using it. One of the major benefits is speed. So with all the additional benefits, Mongoose still provides very good data access speed. So in case you are someone who is looking for a solution that doesn't compromise on speed, but also gives you a lot of good use cases for using object data mapper, then you can use Mongoose. So it provides schemas as well. Schemas can be used to enforce strict validation. So in case you get data from the internet, which is very untrustworthy, and then you put it into your database, MongoDB will take care of the validation. So you can define if you want certain fields to be required, what is the data type of those fields, what is the default value if the user doesn't provide a value, so on and so forth. You can also take a look at validation. So you can validate the schema defining the rules that you want to. So for instance, if you want to validate an email using a custom regular expression that is used to match a particular text, you want to see if there's an @ available and some text before it, some text after it, then a period or a dot, and then a subdomain like com in, so on and so forth. Then you can take a look at validations in Mongoose. They allow you to do that. If you were not using Mongoose, then you would have to do all of this yourself. Utilities. So Mongoose has several built-in methods that allow you to run custom code successful after every query execution. So to give you an example, if you want to append some information about the row that has been fetched, so for instance, how many records were fetched in a particular query, so on and so forth, you can assign some methods to Mongoose and they'll be run right after you fetch the queries. It's very easy to use that way. And it's reduced effort. So Mongoose greatly reduces the time it takes for developers to build the application, since it's taking care of a lot of the internal plumbing and a lot of the internal things that you would have to take care of if you're doing things yourself. Mongoose will do it for you, so you don't have to worry about a lot of the things that otherwise you would have to worry about. Can we build sequence against any transactions in it? So that's the thing about MongoDB and any other things, that transactions are not really a thing in Node.js in particular, mainly because Node.js is just a single threaded environment. It uses something called an event loop, which is something that is a really advanced topic in JavaScript, and you would have to your own or using some of the resources that we provide. But typical SQL transactions are not a part of MongoDB. So that is really something you have to figure out on how to use it. Usually data stays consistent because MongoDB takes care of all the internal threading work and all of that. So you don't have to worry about that at all. Mongoose is the replacement from MongoDB connection string. No, not the connection string. So MongoDB has its own library that it has published. The developers of MongoDB have created a library named MongoDB that you can use in your Node.js or ExpressJS application. So that's not really a replacement, but it's an enhancement to the MongoDB library. It takes care of a lot of the internal plumbing as well. Right. So for this session, we'll take a look at using ExpressJS. So first thing you have to do when you're trying to use ExpressJS or any other library or framework, you would have to have installed Node.js. In case you are not sure whether you have Node.js installed on your system or not, go to your command prompt and search Node-v. Type Node-v. That will show you the version of Node.js that you're using. I'm using 10.16.1, so you can use it yourself. In case you wish to download and install Node.js, you can use the in case you wish to download and install, you can go to the www.nodejs.org. I think that's the website. You can take a look at that and download the latest version and use it. In the hands-on, we'll be creating a to-do API, an API that stores the to-dos, that contains the description and the whether or not the to-do has been completed or not, and we'll model the data. We'll understand how to use it. All right. So the first thing that you have to do, I have already created the API. So let me just go back. I will create another folder and I'll show you how I set up the entire system. All right. So to install these things that you want to install, firstly, you have to initialize a Node.js application. This tells the code editors and Node.js environment that this folder contains a Node.js project and it can be run using Node.js. To do it, just type npm init space --y. --y means that all the basic options that your Node.js is selected by default will use them. And npm is the package manager, which we'll use in just a moment. You press enter, and this is what it has created. Let me just show you if I open Visual Studio Code. By the way, Visual Studio Code is the text editor that I'll be using. In case you wish to use the text editor of your choice, please go ahead. There's no issue with that. All right, so this is the file that command has created. Let's just go through with it and understand what it is. It's the name of our application, the version, description. Since we have not provided any, it's not. Main means the application's entry point. This is the file that we'll be using to start the application. You can change the name whenever you want. Script section is something useful that we'll take a look at in a moment. If there are any keywords that describe our application, we can take a look at that as well. The authors who have created these applications, you can enter your Git username and password, username here, not the password, but the username, so that people can recognize who you are and what other applications you have created. And the license, which shows if someone else wants to download this code and use it, how they can go about doing that. How automatically it got created? So it got created automatically because we run this command npm init -y -y, and that automatically does create this file. This file is present in the root of any Node.js project. So if you have any project that uses Node.js, create this file and then run it. That way you can use npm or the Node package manager to install libraries that you can use with other systems. All right. So can this app work on Linux or Windows? Any operating system can use this application. Node.js is quite cross-platform, so this can be run on any system that you want to run it on. All right. So this is what we have. We have created the API. Now, the first thing that we have to do is we have to install the packages that we will use. So we install those packages using npm. npm stands for Node Package Manager. Node Package Manager is a tool that allows us to get libraries written by other developers that we can use in our code. So we use npm install, and the first thing that I will install is NodeMon. I'll click Save Dev, and I'll explain what that means and why we are using that in a moment. So you press enter. It will contact these Node.js servers and figure out whether or not there's a library named NodeMon, and then it will install it. Since I have already installed NodeMon previously, I think it's available in the caches and it will install it quite quickly. So just wait for a few moments and it will install. All right, so NodeMon is installed. And now I would show you what that does so that you are not confused. And we'll also take a look at the script section. So the first thing I have to do is I have to create a file named index.js. Also notice another thing, that Node modules folder has been created. These are the libraries that you download and install in your system. So we only wanted NodeMon, but since NodeMon has its own set of libraries that it downloads, and those libraries may have their own libraries, it has installed a lot of other libraries as well. You don't typically have to worry about these kinds of things. Someone asked what are those warnings. So those warnings are basically that, let me just show you. That means that when you are, it's incompatible with some things in your operating system, or sometimes it's because it doesn't have the idea, it doesn't have any idea how to use particular packages like fs events. You don't have to worry about that. Since these are skipping the optional dependencies, you don't have to worry about them at all. And also we have not defined any description or repository, so those are the warnings. You don't have to worry about them. Someone else has asked, do we need to be connected to the internet before running? Yes, you do need to be connected to the internet to install these things. All right, so let's take a look at what NodeMon does. Console.log. Hello. This is a typical Node.js application. So if I want to run it, I will Node.js, press enter. Now, as you can see that it is working quite fine, right? But now let me just install Express, and then I'll show you why we installed NodeMon as well. Install Express, Mongoose, and course. I'll tell you what course are. CORS, course, basically means that you are using cross-origin request. It basically means any URL can access the data, can request access to my API. So you can just make it available to the world. That's why we use course. So does this application break in future version of Node.js if we don't update FS events dependency? Well, no, because it's an optional dependency, it has chosen not to install it. So that's fine. It won't break in the future version. You don't have to be worried about that. All right. Now that that's done, let me just show you how ExpressJS works. All right. Firstly, I have to import ExpressJS. And in Node.js, we use the require keyword, right? Create an application. An application is basically a server. Yeah, you can configure Express with that. Right now I'm not bothering with that. And now I'm saying, okay, listen on port 8000, which means localhost colon 8000 is the port. And when you get connected to the server, then just log to the console as we did earlier, hello. So whenever our server successfully establishes connection with the localhost port 8000 on our system, now we're able to run the server. So if I just use the plain node index.js, as you can see, it runs and it types hello. Right now I've not defined any routes, so that's fine. It's not going to respond to anything. But if I want to make any changes to my file, so instead of hello, I want to print connected on port 8000, right? I click save, sorry, 80,000, it's 8. I save it, go back to my terminal, and as you can see, it has printed the old hello. It's not restarted or it's not picked up the changes that I have made. To run it, I have to close it, run it again. Now you can see the new message is showing. Now this is fine, but when you're trying to build a larger application, this could really be a pain to start and stop the server. This is why we use NodeMon. So let me just show you. Instead of Node, I use NodeMon index.js. I press enter. We'll wait for a few moments. In the meantime, I'll like to answer your questions. So someone has asked, can we use any port or is it fixed? So typically any port over 8000 is quite easy to use. A port over 2000 is quite easy to use, although I would recommend that you use port 8000, 8080 or some standard HTTP ports because they are not going to be blocked. Certain ports are blocked for certain other applications, so you might not be able to use all the ports. So now as you can see, it says NodeMon has started. It's watching the file index.js and now the port is listening to its 8000. Suddenly, let's say I decide that, okay, the port is not going to be 8000, it's going to be 8001. Save it. Now earlier I would have had to restart the server. Here as you can see, it's picked up the changes, restarting due to the changes, and started the application on its own. That's why we use NodeMon. And now finally what I'd like to show you is, if I close it here at the screen, I'd like to show you what the script stack does. So sometimes you have a lot of commands that you have to dispatch before starting the server, like setting up the cache, setting up the database, so on and so forth. Now, instead of typing those commands all on your own, Node.js makes it easy for you to do that. I'll just create a dev script. I'll show you what that means in a moment. And I will type nodemon index.js. Save it. Now I can just type npm run dev. Press enter and it will run the same command that we had run earlier and it's going to do the same. So it works just fine. Why is course essential? So yeah, let me just explain. So let me just show you. Now if I were to create a route, I say, okay, when you get a get request to the base URL, which is localhost colon 8000 in our system, let me just change the message that is incorrectly displaying. What you have to do is you have to log to the console, or not log to the console, send a request and response. Let me just show you. You get a request object, you get a response object, and then you just send what. I click save. Let's see. So it has restarted our system. That's fine. And now I'll go to the localhost colon 8000. Press enter, and as you can see, it's showing working. So what happens is when you're trying to build an API, this is your server. Let me just show you. So it will have certain components. It will have a server, it will have a client, and it will have a database. So the server and the database are connected to each other, and the client is connected to the server. So what happens now is this. Client makes a request to the server. Client could be anything. It could be a web application using React.js or AngularJS. It could be an Android application, or it could be an application of another type. So those applications are deployed on other URLs. Your Android application can be connected to your local Wi-Fi system. So when it sends the request, it would have in its header the URL of that IP address. Similarly, and your web app could be deployed on Amazon web servers on some other server than your REST API server. And then when your client tries to make the request, it sees the URL is different from its own, and it will reject the request, saying that it's come from outside my domain. I am going to reject the request. To make it pass, to make it seem that there needs to be no rejection of the request, we use the course API. So to do that, it's basically as simple as app.use course, and I have to import it. So you can just import it here, CORS, sorry, require course. Now it's going to use that. I have to use it. Yeah, now it's going to. So that's how you can configure your application to accept requests from other domains as well in Node.js. In other applications, you would have other scenarios that you can take a look at. Now, instead of typing all the code, what I'm going to do is I'm going to kill the server. Now that you know how to set up your basic API, I will go back to Run API. I will open it up in Visual Studio Code by closing this first. So it's opening up. Here we have it. Yeah, there you go. Here we have it on our own system, and I have created all the files. I have created all the code that's required to create a web API. So can we create a cron job to read REST API or update API? So yes, you can create a cron job. Cron jobs, for those of you who are unaware, is a tool that's used in Linux to schedule certain tasks for certain periods of time. So if you want to run particular script every 10 minutes, you can use cron jobs for that. So you can use that as well, although it's not really necessary in most cases. So it's the same thing that we had earlier. As you can see, it has the same dev script. It has the same dependencies, Node, Mongoose, Express, and Mongoose. One thing that you can notice is that Express, Codes, and Mongoose are in dependencies, and NodeMon is in dev dependencies. This basically means that when you are trying to deploy the application, Course is not something that needs to be installed. So in production environment, you don't need to install NodeMon, mainly because NodeMon is something we're using for development. We need to restart the server when you make changes, only when you're developing the application. When it's in production, you're not going to be making changes like that. You have to restart the entire server. So that's why we have put it in development dependencies. Now, let's take a look at ExpressJS. Whenever you're building a REST API, make sure that you are able to separate the code easily. So as you can see, our index.js, which is the main file, is quite simple. All it's doing is it's requiring the application from the server module. I've divided into two modules, persistence and server. Persistence handles the database interaction. Server interacts with the web server. In the index.js, we tell it to listen on port 8000 and log the message on the console that it's listening on port 8000. Hopefully you can all see my screen. If you need me to change to other themes like the dark theme so that you can watch it or read it easily, you can ask in the chat box and I'll do that. All right, so this is the code that we have written so far. Now let's take a look at what is index.js is doing. This is where our entire server is getting configured. Since we are only using a to-dos application, it's not really important for us to break it down into smaller pieces, but in a bigger application, you would have to. Now what we're doing is we are creating an Express app. We are allowing it to be accessed by other platforms, and we are using express.json as well. This allows ExpressJS to parse JSON data. So as I already told you that it is unopinionated. Express doesn't know what kind of data you are expecting from the clients, whether the data is formatted in JSON, whether it's formatted in binary strings like form data or XURL encoded, or whether it's just data that's going to come from a file. We have no idea. So that's why we use express.json. We configure it, we configure course, and now this is where the database is being used. We have created functions that will interact with the database, which will find all to-dos, find a to-do by ID, add a to-do, update a to-do, and delete to-dos. So let me just open up the persistence. Here I have created an index.js. So in every module, there's an index.js file which will expose all the things necessary in your application. So we've got a question. Can this API be used for SQL servers or application based on SQL? Sure. If you want to use SQL instead of NoSQL, a good way of doing that would be create another persistence module, call it SQL underscore persistence, and make sure that it exposes all the same things that we are exposing. So when I import it on my side, I should get all these functions. And if I do, then you don't have to change your server at all. Just create a new package that handles the interaction with the SQL databases and just import it. That's the easiest way to go about it. All right. So here what we do is we create a function. In case you don't understand JavaScript, this is going to look really weird to you. We are creating importing the Mongoose database API. Then we are assigning a promise to it. Promise is an advanced JavaScript feature which I won't be discussing right now, but we'll guide you through some of the resources through which you can learn this. So stick till the end of the presentation. And here we have we're connecting to MongoDB. On MongoDB we have localhost :27017, which is the default port. This is the URL that uses MongoDB on my system, and I want it to use the to-dos collection or to-dos documents. Here we have for certain configuration, so you can configure it the way you want to. Use new URL parcel and use unified topology is basically how you configure it. Don't have to worry about it right now, but if you don't do it this way, then you get some warnings, and I didn't want to explain those right now, so don't worry. And here we have configured some error logging. So what we have said that if you get a problem when connecting, log it to the console, print it on the console so we can take a look at it and understand what actually went wrong. Otherwise it will just die silently. And once you get connected, print connected to the database. So we'll take a look at that also. And right now we are just exporting everything that we get from todo.repository, which is a file that's right here. So let's open that up. This is todo.repository. We go to the top, and the first thing it's doing is it's requiring a to-do from todo.model. If I open it, this is where the schema generation and all of the things that we have described Mongoose doing happens. We require Mongoose, we create a schema, we tell it what are the things that we're expecting to store, a description and a done field. Description needs to be string and it is required. Done is boolean and the default value is false. So it's not required the person gives us the done value. We'll just default it to false. So that's now taken care of by our database layer instead of our application layer. And now we create a model out of the schema and we return it. So now our repository will access this, and now we create the functions that we want to expose. So we create find all to-dos, which with using MongoDB, like I said, you can use the documents and you can use the objects quite easily. So use the to-do model and you say find me everything. Here you can, inside the brackets, you can define certain filter options like find me the record in which to-dos are not completed. So the done field is false. But right now we don't want to do that. We want to find everything. So we do this. Also find to do by ID. We give the function an ID and it returns a to do. Add to do is quite simple. You get the data from the parameters that have been passed to it. You save it inside the to do. You create a new to do with the parameters and then you save it. The reason why I'm extracting these is because the parameters could have other data fields as well, and we don't want to save them inside our database. So we save it and we return the result. Similarly, if we want to update it, what we do is we get the data, we find the data that we want to update, we then update it, and then we return the updated collection. And similarly, to do it with the delete option, we do the same thing. As you can see, I've done this here in a single line. I can do this here in the single line as well instead of breaking it down into getting the to-dos and then returning the to-dos, but you can do it if you want to. And finally, I expose the things that I want to expose. If there was a utility function here like log things to the console or something like that, I would not have exposed it to be used by the external APIs. So that's how we do that. Let me just, yeah. So everything looks fine. And now we have understood how repository works. So we go back to the server and see how this works. Let me just close all the other things so that you can easily understand what's going on. Now we set up a route for slash to-dos. So when I go on slash to-dos with a get request, I want you to find all the to-dos and send it back to the user in the response. Now to interact with our API, we'll be using a program called Postman. There are other programs that can allow you to use the API, such as Insomnia and so on and so forth. But I use Postman because it's quite easy to use. I have created certain requests, so you don't have to. You just create a request like I have done here. It should be a get request. It should go to this URL. When I click send, it should fetch me any to-do that I have created. And it says connection refused. That's because I have not started the web server here. So I can run the same command that I had run earlier, which is npm run dev. And since both of the programs have been configured the same way, it's going to use it the same way. Now do that. It's listening on port 8000, and now hopefully if I try it out, it'll work just fine. So you send it and it returns a to-do that I had created earlier to check whether or not the API is working. So it's working just fine. So let's take a look at what's happening here. Basically, it takes a get request, which as you can see, we have created a get request. This is the request that tells us these are the other kinds of requests, all other kinds of requests that are available. The ones we are interested in are on the top. So we use the get request, get the data. We call the find all to-dos function, await the result because it's going to take some time to get the data from the database, and then when it gets it, sends it back to the user. Similarly, we find the data from a to-dos by passing it an ID. Now, as you can see, there's a colon right in front of it. This means a dynamic parameter. That means that the user can specify the value for this. Let's check. So this is not the thing that I want to use. Get to do by ID. So since I have created a to do already, use its ID. You pass in the ID in the URL, send the request, and as you can see, it gives you the ID of that. Now I can change the ID to be anything. I see we have got a question. Do we need to have an ID, MongoDB ID, or can we replace it with any of the user ID? So you can create user-defined IDs, which could just be what is it? It could just be a serialized number. So the first record will get 1 as an ID, second record will get 2, so on and so forth. But it is recommended that you make it to have randomly generated string IDs, and MongoDB does it automatically for us. It's good from the security perspective. So you should do that here. So what we do is we get the ID and then we pass find to do by ID, the ID that we get from the URL. So it goes to the request, takes a look at the parameters that have been passed. In our case, we have defined only one named ID, and since since ExpressJS takes care of the parsing of the request and populating the request object, it takes a look at the parameters and creates an ID parameter there. So we just pass it and get the data back from the MongoDB database. Now we take a look at the post method, which is used to create a to-do, which is what this helpful comment is showing us. To do that, all you have to do is go to the create to-do function. As you can see, it's post request that this label is showing, and also you can see here in the post request, since we're using JSON, I have to pass in some data. Let me just pass in some data. I'll call it to-do 1, which means the first to-do, and it's not completed. I send the data. I return back the ID. If I want to check if it has been persisted, since we've gotten the response, it has been persisted, but if you want to check, you can take a look at all to-dos, and as you can see, Our to-do that we had completed earlier is there, and this one is here as well. And we can take a look at the to-do created just now as well. And as you can see, it has been returned. Now we come to update. So you go here. To update, we can use the put method. Also, you can use the patch method as well. Both of them are almost the same. In put, you define, you say that entire entity has been updated. In patch, only a few fields of this is updated. So you can use patch here as well. It doesn't really matter. So what we do is we get the request ID and the body, and we send it to the users. So let me just open Postman. This is the ID. I'll just pass in the ID of the newly created to do. And what do we want to replace it with? So instead of it being to do /1, I can make it important to do, and I'll change the done to true. Send back. It'll respond with everything, and this is what has been updated. So now if I take a look at this, send the request, and as you can see, it has been created. Now as you can see, I have misspelled it. That was on purpose. Now I can just go important. It returns the thing that it was before I updated it. So it looks like this. It looked like this, but now it has been updated. So if I click on this, now as you can see, this is the earlier spelling mistake. And now if I take a look at all the to-dos, it has been updated and it's correctly spelled. Finally, we have the delete option. Again, the delete option is quite easy to understand. Let me just show you. You go to app.delete, which means look at the delete function. If any URL that comes to /to-do/ with a random ID and it's a delete method, then perform this code. We delete the to-do, we get the deleted to-do, and we send it to the user. So now if I want to delete a to-do, all I have to do is I have to pass in the ID. So since the new ID is, let me just check. I think the ID is this. And if I want to delete it, I can just go and pass in the to-do, pass in the ID, send, and this is the to-do that has been deleted. Save it. And now if I try and get all the to-dos, as you can see, instead of 2, we only get 1. So that's our API. It's quite easy to build an API. It takes a little bit of time, but it's done. In case you have any questions, please do ask. Let me just take a look at the questions that I've been asked so far that I haven't addressed, and then we'll move on. All right. So someone has asked, I believe for REST API, we don't want to give session ID in the request, but you have provided in the request. So this is not a session ID. This is the ID of the user. Or ID of the, not the user, but the ID of the database that is inside our data. So this is really a judgment call that you can make in case you don't want to use databases, in case you don't want to display the ID, you can just leave it out. But then the user would have to know the ID because that's how they are going to ask for a particular data. So if they want to get a particular tutu, they need to know what the particular ID of that tutu is. So that's why we use that. All right, someone has asked any prerequisite. Yes, you need to know the basic HTTP request. You do need to know particular subsets of HTTP request response cycle. You need to know a little bit of HTTP and so on and so forth. But there's no something that you can't learn on your own. And we'll also guide you through some of the resources in just a moment. So we can protect the delete or put request using some, yes, you can use some authentication, but the point of this session was to show you how you can create a basic API. In authentication, you would have to take a lot of time. So that would be a difficult thing. Okay, is this in this any format restricted Excel or PDF? Well, we are sending the data and receiving the data back using JSON data. So you don't have to worry about that. You can use PDF and all, but I would really recommend that you don't use PDFs. You can just explain show the data in HTML page, which they can then print out in HTML themselves. So you don't have to do anything about that. asked, can we use cloud as a server from REST API? So this application that you have created, you can deploy it on a cloud such as AWS or any other service, and that will run this API for you on the cloud server. So that's why you can use that in case you want to. All right. So the workflow step is this. Let me just close the API. Firstly, you create a folder in which you are getting down and understanding what the problem was, and then creating smaller modules in which we'll be using. So we needed a server and a persistence module. The reason why I called it persistence is because you could either use databases or you can use other things such as you could use databases or you can use flat file system. You could use any other database as well. So inside you create the database code and expose it using the index.js. Only expose the things that are needed to be exposed. So they don't need to know how to connect to the database, so you don't expose that. After that, you create the server. Inside the server, you define the routes and you define the actions that need to be performed when a particular route is hit. Also, one thing I'd like to mention is that this is by no means a complete API. You need to take care of a lot of things like the validation of the data and also probably things to do when user uh, user asks for some data that is not available in our database. And then finally we create our application, which we import the server, and then we start it, then start listening on port 8000. So that's how that works. What would be distributable for API? So for API, all you have to do is let me just open up my folder in which this is in. Leave this folder. This is the node modules folder. You can delete it as well, and share these files. Copy them on your server, store it inside a zip file, and then deploy it whatever you want to. Create a Docker container and then deploy it however you wish to do it. Just don't include the node modules folder. The reason being that when you deploy it on the server, what the server will do is firstly it will take a look at package.json. Inside it will take a look at the dependencies that you have specified, Codes, Express, Mongoose, and it will download it for your application itself, and then it will use it. So will other people as well. So that's how you would do that. All right. Hopefully this has been informative for you. Thank you so much for sticking around till now. All right, guys. So thank you so much for joining us for this session, and we'll be ending the session, and you'll get all the questions, all the PPTs, and all the code on your mail as soon as we can make it available to you. So thank you so much, and we'll see you next time.
Just a quick info, guys. Intellipaat offers a full stack developer course which enable you to learn tech stack from both front end and back end. Through this course, you will gain hands-on experience with the skills and technologies such as SQL, Java, data structure, JavaScript, HTML, CSS, Node.js, and React under the guidance of industrial professionals. With this course, we have already helped thousands of professionals in successful career transition. You can check out the testimonial on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your careers to new heights. So visit the course page link given in the description and take the first step towards a career growth with the full stack developer course.